Hello Internet, welcome back to the workshop. In today's video, we're going to use the Walker-Turner mill press to make a new shaft and fit a new bushing in the drive gear for the surface grinder. If that interests you, stay tuned, we'll get started. So this is the shaft and bushing that came out of the drive gear for the X-axis on the surface grinder table, and I'll show that to you in a minute. But this one is quite badly worn. There's about 50 thousandths of wear between the bushing and the shaft. So I need to replace this. I need to replace both the bushing and I need to make a new shaft. So that's what we're going to do today. We're going to take a new bushing. This is an off-the-shelf bushing. We're going to replace the one on the drive gear, and then we're going to make a new shaft using some 3/4 inch hardened shaft stock. So let's go over. I want to show you the table and how that gear works, show you where this fits, and then we'll make a replacement. So the way this table works, the X-axis moves back and forth, and it's controlled by a set of gears. So this is the largest gear. This is the one that interfaces the underside of the X table. And this one had a bushing pressed into it, and it rode on this shaft. Now fortunately, this is a standard size shaft and bearing, so I was able to order replacements from McMaster Car. So the bushing that was in the large gear, it had originally been pinned. I didn't realize that when I pulled it out and I distorted it. But I'm going to pin the new one in the same spot. So this should be really straightforward. I'm just going to drill the same size hole in the same location. And then after I press it in place, I'll tap the pin back in to pin it. That's the pin that was in there. I'm going to just drive it right back in. I totally nailed the alignment on my pinhole there, which is nice. I assume all that does is keep that bearing from rotating. It's a pretty tight press. I don't know why it would. But that's this side of this done. Let's work on the shaft now, get it made. This is the original shaft that gear rode on. And this is the new one. We've got to make this look like the original shaft. There's not that much really to do. I mean, notable difference is this one's a little long, so I'm going to have to cut it down to the same length. This one's got a flat ground on it for a set screw that holds it into the table. And then I think probably most difficultly, this one has been through drilled, and oil would flow in from the top of the table into this channel, into that hole, and then into the center. And that's what it would use to lubricate the bushing. So I need to cut it to length. I need to cut this groove in it. I need to drill it and then tap and install a set screw. So let's start there. I'm going to put it in the mill and we'll cut this flat. So I don't know how well this material is going to cut. It's a hardened shaft. I don't know the rock well. I can look it up and I'll put it on the screen. But I'm going to try cutting it with a Carbide End Mill. That's how that turned out. I think it looks alright, especially considering how hard it is. So I've got that flat cut on the shaft, and now I've got the shaft fitted back in here. And with that new bushing, this thing it's good and tight. It feels really nice. So I spent some time last night clearing the oil passages. Somebody had plugged them with steel plugs. This machine had the automatic table pretty much removed from it, and I'm suspicious that they blocked the oil passages at that time so that the oil would flow only to the ways. Otherwise the oil flows down and you lose most of your oil in this gear train. So I drilled those out. I got all the oil passages clear. Now when I put oil in the oilers, it flows to where it's supposed to. So the last thing I need to do on this shaft is modify it so it will accommodate that oil flow. There's two things I'm going to do with it. I need to bore out the end so when the oil comes down from the reservoir, it can get into the center of the shaft. And then I'm going to drill 2 holes in that shaft so that the oil will then flow into the bearing. So I'm going to take this back out of here and I'm going to grind the case hardening off the end, and then we'll drill it, and then we'll drill the through hole. So I've got the shaft chucked up in the lathe. I'm going to try and cut that hardened edge off with a carbide bit instead of grinding it. So that's where we're going to start. So we're going to take that case hardening off the end, and then we're going to drill it out. That's 1 3/4 inch in, which should put me right in the center of that shaft. Let's get it out of here, and then we'll tap that hole so I can put a set screw in the end. All right, I think that's probably good enough. So now we've got a flat for the lock screw. We've got 1.5 inches or 1 3/4 inches, which is half the length of this, drilled out. The next thing I need to do is drill the holes for oil supply in and oil supply out. The way I'm going to do that, I'm going to put this back in the mill so that I can cut a flat to give me somewhere for a drill bit to start. This little bit may not be tough enough. In fact, I'm certain it's not, looking at the tip. So, let me take a little more off. I need to cut a relief in the shaft now that everything else is done, so that when the oil flows through, it allows it to move through the length of the bushing. Ideally, I'd use like a little 1/16 inch ball mill and just cut it straight with that, but I don't have one. So what I'm going to do is I'm going to stick with the same 1/4 inch end mill that I've been using, and I've got the shaft in here rotated at a 45 degrees, and I'm just going to cut a small V. It doesn't have to be big, just enough that oil can flow into it. So that's how that turned out. I'm really happy with it, considering the tools I have at hand. So now I want to put everything together, and I want to put some oil in it and make sure it's oiling and working the way it should. The bushing I used on the gear is an oil-light bushing, so I don't need to cut grooves in it for oiling. It's a sintered bushing, so there's already little tiny oil passages in that bushing. So getting oil to this point it will then soak into the bearing and it should lubricate really well. So I want to get it put together and just do a quick test. So I marked it here so I know when the orientation is correct when I install it. Slot side facing towards me. Alright. Get it to where it sits where it needs to. Alright. Let's tighten down this screw and see how it rolls. Oh yeah, that feels really nice. So I'm going to lay this flat now. We're going to put oil in it. I want to just spin it over and make sure that works. So I'm going to fill this up with oil and then roll that gear around, and I want to see how things look down there. See if I'm getting any oil at the end of that shaft. Alright, I do see a little bit of oil. I don't know if you can see this, but right here, that's worked its way out between the gear and the casting. So I'm going to push this out. So we do have oil at least into this point, quite a bit of oil. So that means it's getting down through, it's getting out, and it's lubricating our bushing. I don't know if I pull the bushing out or the gear out. Oh yeah, this thing is well oiled. That's awesome. So that turned out really nicely. This is a short video. What I really wanted to do is show you guys how the Walker Turner mill press machines, and I thought this would be a good project to start with, since this is a hardened steel shaft. I don't remember, like I said, I don't remember what the Rockwell number is, the hardness, but I'll put that on screen so you have an idea of what I was working with. So I hope you enjoyed this video. I hope you found something here useful. If you did enjoy this video, would you consider subscribing to my channel? My channel is super tiny and every subscriber helps grow the channel. So if you liked it, consider subscribing. Super thrilled with how this turned out. I hope you guys think it turned out just as good as I do. So with that, thank you for watching.